On Wednesdays, we are pink the 23rd of September. Students will be able to form and interpret compound statements and truth tables. Section 2.2, so compound statements and truth tables, okay? You don't have to put your name on this section since we have them all packaged together, but if you would like to, you can put your name, me llamo Profe Castle. Okay, so a statement. A statement is a sentence that is either true or false. Okay, if someone says a statement, okay, that's something that can be true or false. Now, whether or not it's called true or false is called the truth value. We're going to assign a value to it. Might want to walk. But, okay, we assign a value to it, whether it is true or false. Okay, Bill?
Is it Profe, like the girl name for it?
No, it just means like professor.
No, I mean, Profe is
He's always right. He's never going to be wrong.
Maybe. Anyway, so we represent statements. We represent statements by letters such as P or Q. P actually stands for proposition. P stands for proposition, okay? Because a lot of times this is termed propositional logic, okay? Based on a proposition, what happens, okay? Different truth and false scenarios based upon the proposition. So P stands for proposition. I cannot remember what Q stands for. I learned it once back in college when I took a class over this. That was more in depth, but I don't remember it anymore. Hey, Riley.
Yeah.
Okay, probably. Okay. So an example, you could have statement P. Supplementary angles have a sum of 180 degrees. What's the truth value of statement P? Do the supplementary angles have a sum of 180 degrees? Yes, so the truth value is true. If it wasn't true, it would be false. Negation. A negation of the statement has the opposite truth value. So if you negate something, you're doing the opposite of it, right? You're not allowing it. You're saying no, okay? Now we have a symbol. We have symbols for lots of stuff in geometry. We do this little squiggly, okay? So you could have P for your statement, and you could have not P. So that squiggly means not, and it even says there, read as not P. You don't just say squiggly P, you say not P. Yes, Bill?
Isn't that the symbol for one of the other things?
Great question. So we put that over the equal sign, and we called it congruent.
Yeah.
And then we also put two of them together and said it was approximately. But as one by itself, and in this will just mean not. An example, not P. So we had P up here, supplementary angles have a sum of 180. Not P. Supplementary angles do not have a sum of 180 degrees. What's the truth value of that? False. Supplementary angles do not have a sum of 180 degrees. That's false, because they do. And, just like we said, it has the opposite truth value of what our statement was. Question on that. Okay, compound statements. What would it mean? What do you think a compound statement will be? More than one. Okay, and we're going to put them together. Okay, so compound statements are going to be two or more statements joined by the words and. I'm going to capitalize them just to make sure we know they're important. Or. So we're going to use the word and we'll use the word or to join these statements together and call them compound statements. So we have two different types based upon whether or not we use and or or. And it's going to be conjunctions and disjunction. Okay, conjunctions or disjunction, okay? Think conjunction like in English class, right? Okay, and would be a form of a conjunction, okay? Statements joined by the word and. So if you use the word and to join them together, it's a conjunction. We write it using this symbol, kind of like the caret in English that you use in proofreading to say you're inserting something, okay? So you say P and Q. You would read that as P and Q. Okay? Can't read? What do you mean?
You cannot read.
He's unable to hand.
Okay. It's true. So when we have a conjunction, the truth value of the conjunction is true when both statements are true. So if we say this and this, okay, these two statements together with and, they have to both be true in order for it to be true. We'll talk about what this means. It's probably confusing at first. That's okay. We'll talk about them. We'll give examples. Okay? Then we have our disjunctions. Disjunctions are statements joined by the word or. And our symbol for P or Q is actually just going to be the other direction. Okay? It's just going to be upside down. It's going to look like a giant V. It's going to be like upside down.
It's like less than, greater than,
Yeah, it was like you flipped them over. Okay? A bunch of people were upset. Flip it over. Okay? So one way I help to keep these straight, because these can get confusing. So one way I help to keep them straight is for P and Q. I think, okay, the and, well, when it's with the P and Q, when it's kind of like level with it, like height-wise, so to speak, it's touching them. So it's going out to meet P and Q. Going out to meet P and Q at the bottom. Whereas the or, well, when it's coming to the bottom here, it's coming. It's not coming out to them. It's going in halfway between them. So it's not. It's not. So let me restart that. So the and, I think of it this way, and the or, I think of it, well, it's really going out and up rather than going out and down to them. Okay, does that make sense? Okay, no. Okay. So here I think of these as they come together at the top, whereas here I think they start apart. So I'm trying to help this make sense. Okay, maybe this looks more like an A
It just looks
for
like,
and.
like an up arrow.
How about this? This more like an up for A for and,
Okay.
and this doesn't.
Okay.
A for and this one's the other one.
That's better.
Okay? Otherwise, you can just straight memorize them, but that's a little tip to maybe help you memorize them. Okay? Maybe that second one landed a little bit better with you guys. Okay? I think it did. Okay? So, this one's true. So, when disjunction is true, if you use or, it's true when at least one statement is true. So, for and, you need them both to be. For or, you just need at least one. And like I said, we'll practice a couple of these so we can actually know what we're talking about, because otherwise it's confusing. Everyone have this down. Like written down.
I think so.
Okay, so these examples here, okay? So we're going to be given three different statements. We have statement P, statement Q, statement R. You could keep going through the alphabet and have more. We're going to do three statements P, Q, and R. So given the statements below, we're going to write the compound statements, then determine the truth value. So we have these three statements, and then we have P and Q, Q and R, P and R, and we can form these compound statements together. So each of these individual statements have a truth value, and then each of these conjunctions will have a truth value as well. There are 7 days in a week. Is that true or false?
True.
Okay, that's true. Let's make ourselves a little bit note. T for true. Okay, that is true. March has 30 days. Statement Q. Is that true or false?
False.
False. How many days does March have?
31.
31. Okay. Now, if it said March has at least 30 days, that'd be different, right? But it says has 30. Halloween is on October 31st. It's R, true or false? True. Okay? So we know individually these have their own truth values as well. So if I said, what is P and Q? How would I combine those? I would say there, I'm just going to write it out. There's going to be a lot of writing. There are 7 days in a week. And remember, this means and March has 30 days. Now, those might be unrelated, right? Like, what is a week having 7 days and March maybe having 30 days have to do with anything? Okay? What was that?
No, because it says so.
It'd be the A for and.
Okay?
It
But
still says a
this is what it says, so this is what we'll write. Now, that's a whole different scenario, Bill, we'll get into in a bit. There are 7 days in a week, and March has 30 days. Okay, for and to be true, for these conjunctions to be true, we said both had to be true. Are both P and Q true? No, so this statement is false. There are 7 days in a week and March has 30 days. That's not a true compound statement because one of them is false. So it makes the whole thing false. Does that make a little more sense maybe than it did earlier? Okay, I'd hope so. Okay, let's look at number 2 together. Q and R. Q and R. Can somebody help me maybe write this? Exactly right. March has 30 days. And Halloween is on October 31st. So March has 30 days and Halloween is on October 31st. I'm just going to write Q, March has 30 days, write and then R, Halloween is on October 31st. Now, is this compound statement true or false?
False.
It's false because it's and, so they both have to be true, but they're not both true. Q is false. Okay? Questions on number 2. I want you guys to try number 3. Very good. There are 7 days in a week. And Halloween is on October 31st. Now, is this true or false?
True.
That's true, because both of them are true. So this is a true statement. Now, do these have anything to do with each other?
No.
No, but you can still say, as a compound statement, it is true. Questions on that? All right, if we flip our page over, we have some more examples we're going to do. Okay? So if we flip our page over, we're going to have some more examples we're going to do. And we're not going to do all of them. Okay?
I don't really get this negative P.
Oh, man. Look what's up on number 4, though, for us to practice.
Nice.
Convenient. All right. 4. What's this little squiggly mean? Not. Not P and Q. So we're going to take P, but we're going to make it the opposite. So what is the opposite of there are 7 days in a week?
Not.
There are not 7 days in a week. We're just going to add the word not. Now we're going to add the word not somewhere where it makes sense, right? We're not going to say there are 7 days in a not week. Like you wouldn't add not there, right? You're going to put it where it makes sense, okay? There are not 7 days in a week. Okay? And then and Q, March has 30 days. Now, this didn't say not Q. It just said not P. Okay? So Q, we still write as normal Q. March has 30 days. Now, once again, I'm going to put our truth values up here that P was true, Q was false, and then R was true. So, not P and Q. What's the truth value of not P? False. It might be helpful to write that in there, just for you guys, okay, as you go through these. What's the value of Q? False. So, false and false. What's the truth value of this compound? False. It's still false. They need to both be true in order for it to be true. It's not just necessarily both the same. They both need to be true for it to be true.
Got it.
Okay, question on that one. 5. What's different on 5 here? It's a disjunction, which means it's not and, it's or. Okay, it's not the A, it's the other one. Okay, it's or. I want you guys to try number 5 here. P or R. Who can help me with this one? Okay. Levi.
There are 7 days in a week, or Halloween is on October 31st.
Okay, so there are 7 days in a week, and then I like the emphasis you put there. See what I did there? Emphasis to the emphasis. Anyway, okay. 7 days a week, or Halloween is on October 31st. Very good, very good, very good. Now, is this true or false? True. For or statements, at least one has to be true. In this case, they both are, but as long as at least one of them is. Yeah, but it's not asking it as a question. So it's saying like this or this, which one would you pick? It's just saying like, well, is at least one of these true?
Yes.
Kind of a thing. Oh, nice. Okay, I want you guys to try number 6. Not Q or R. Number 6. Liam's gonna hook me up here. Go ahead, Liam.
March does not have 30 days, or Halloween is on October 31st.
Very good. March does not have 30 days. Or Halloween is on October 31st. What's the truth value here?
P.
True. They're both actually true here, but only one would need to be. But they are both true because March does not have 30 days. It has 31.
So if like if you mess up like P and you think that it's false, then like you get all of these.
Yeah. So if you mess up one of these, you can end up getting a lot of them wrong. So it's good to make sure that we know that they're right or wrong at first. Okay. We'll do one more. Okay. We'll do one more. We'll do number 8. We'll skip 7. We'll do number 8. Not P or not Q. Go ahead. Sierra, can I have you help me with number 8?
There are not 7 days in a week where March doesn't have 30 days.
Very good. There are not 7 days in a week. Or March does not have 30 days. Now, what do we think the truth value of this disjunction is?
True.
It is true. Because even though not P is false, not Q is true. As long as one of them is true, we're good. Question on that. Create your own? Nah.
Hey, golden.
Where are we going? Bless you, must read down after this forget. Bless you, must read down after this forget. Continue to the next page. Truth tables! This is a lot of formality. Okay, a lot of formal process through this, okay? So paying attention to how we order things is going to be very important here, okay? Truth tables are a convenient way of organizing truth values of statements. They become handy once you have pretty long propositional logic trains, okay? When you have pretty long propositional logics together. We're going to complete the following negation, conjunction, and disjunction truth tables. So we're saying on the left-hand side, here's our scenario. So on the left-hand side of each of these, you have your statement or statements. So here, very far left, you start with your statement P. Very far left, statements P and Q. Very far left, statements P and Q. If you were to have more statements, they all go on the far left. We usually put them in alphabetic order just for convenience. So here, we go down and we say, here's our 2 different options. Either P is true or it's false. Is there another option for P? No, it's either true or false. So for now, we're talking about the negation. Well, if P is true, what is not P?
False.
Okay, so we put false. We say in this scenario, that would be what follows. It's false. It's a really bad F. Now, if P is false, what is not P?
True.
True. So we just organize it like this. We're just saying, okay, well, based upon our setup, this is how it goes. My goodness, these are like really bad letters. There we go, that's much better. Okay? Questions on this table. In our next table, our conjunction. Okay, this is our and. Okay? So we have our P's, we have our Q's. Now here's our first scenario. Both P and Q are true. What would our conjunction would be true? For and, they both have to be true. Our second scenario. P is still true, but now Q is false. That's false. Because they both have to be true. So now, we covered both scenarios where P is true, didn't we? So now we have to start talking about scenarios where P is false. Well, P is false, but let's say Q is still true. What would happen?
False.
Okay, and now what about if they're both false?
False.
Are there any other scenarios we missed? No, okay? A good way to do this, guys, as we keep going through them, is your first statement will always have the first half of however many rows. So in this case, there are 4 rows. The first half will be the true. The last half will be false. In this case, since there are 2 rows, the first half 1 is true. Second half is false. Here, 4 of them. First half is true. Second half is false for our first statement. That's a good way to help us make sure we don't miss scenarios. Okay? Now in our disjunction, let's say they start off, notice the order is the same. True, 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 false, false, true, false, true, false, 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 false. The order is the same. We keep this systematic way just because it helps us stay organized and not forget anything. So if they're both true, what's our disjunction? What's our or? It's going to be true. Now what about just if P is true but Q is false? That's still true. What about if P is false but Q is true? And what about if they're both false? False. So here's some tips for making those truth tables. I talked about some of them. We include columns for each statement involved. P, Q, R, etc. And I also added that we put them on the far left. Next, you'd have any columns for any negations. So next you'd have columns for negations, okay? So maybe put first, you put the second, and then lastly, hence third, include columns for compound statement or statements. So if you'd have negation and a conjunction in the same truth table, you'd put the negation before the conjunction. Okay, we're going to try this out. So if I have this statement, okay, we're going to construct truth tables for the following compound statements. P or not R. I'm going to first start off with my top column giving me kind of the headers, the labels. So I'm going to start off with my statements. So what statements do I have here? P, and I have one other statement, one other letter. R. I'm going to put regular R first. Because regular R is a scenario even though we don't see it here. So we have the two statements, P and R. Now, after I put my statements, what do I put second? Go back up to our tips right above this. What do I put second? I put not R. I put any negations. Okay? And what's going to go last in my last column? The whole thing, the conjunction, or in this case, the disjunction. Excuse me, the compound statement, the disjunction. P or not R. Now we're going to start to see, hopefully, why these truth tables are actually helpful for us when we get to the last column. So to fill in my first one, I'm going to start off with my P, and I'm going to do the first half as true, the second half as false. True, true, false, false. And this is going to help me come up with all of my scenarios. Now, if P is true, what could R also be? True. If P is true, what's the other scenario? The R is?
False.
Okay. If P is false, let's start off saying R is true. And let's start saying if P is false, R is false. So did we cover all four scenarios so far for these two? Everything will be based upon our statements. So we have to start with our statements, and everything is based upon our statements. Notice the second column, alternated. True, false, true, false. Okay, that's going to be a theme we'll see here with our last statement. Now, not R. So if R is true, what's not R? If not R is false, or if R is false, you mean not R is? Once again, false, true. Now we should notice our R and our not R should be exactly opposite of each other, right? That should happen on purpose because the statement and its negation are always opposite. Now we're going to look at P or not R. For this to be true, how many of these need to be true? One or two? Just at least one. So we're going to look at P, and we're going to look at the not R column. So we're not even going to look at this R column yet at all. We just used it to help us make the not R column. We're going to look at really only at the first and third columns because that's all this is concerned with. So in the first row, P is true, not R is false. So what's our truth value? Okay. Second column, they're both true. So what's our truth value?
True.
Third column, or third row, excuse me, they're both false. So what's their truth value?
False.
And then our fourth row, one's false, one is true. So it is true. I think it's pretty neat. Okay. Questions on that? Okay.
How come we always put P first?
You just put them alphabetically.
Oh, yeah.
Yeah.
Comes before R.
So let's look at the next one. How many different statements do we see here? We really see two. What letters? P and Q. Okay. Then after we put all of our statements, after all of our normal letters, what are we going to put if we have them? Negation. So in this case, we have not P. And then last, we're going to put any conjunction or disjunctions, our compound statements. We're going to put not P and Q. So let's fill this in. Who can help me fill something in here? Who can help me know where to start? Kelly.
True, true, false.
Start with P. True, true, false, false. We're going to do our first statement. We're going to do the first half true, second half false. What would I do next? What would I do for my Q's here? Can somebody help me do my Q's? Okay, Gage.
True, false, true, false.
True, false, true, false. I'm going to alternate them. And this is just a helpful pattern that helps me to get all the scenarios here. Okay? Now, based upon that, we're going to continue. Once you have all your statements filled in, it's kind of like your structure and your outline, so to speak, and now you can fill in the rest. So, not P. What would my not P be top to bottom?
False, false, true, true.
Very good, Dominic. False, false, true, true. It's just going to be the opposite of whatever P was. Now when I go to my last column here, not P and Q, I would need to look at which two columns, the first, second, or third. Which two would I look at?
The first and third. Oh, sorry.
Second and third, Q and not P. Or not P and Q, the second and third. And what do I need them to be? Do I need one true or both true here? Both, because it's and. So what's going to be my first row?
False.
Okay, second row.
False.
Third row.
True.
Fourth row.
False.
So this is a helpful tool to help us get to the very end very end time. If I just said, "Hey, how many scenarios are this for? Can this end up in, and what are they?" You might be a little bit lost, right? Like how many different scenarios can we have where this is true or false, and what are the scenarios? You might be lost, but when we do this table, it helps us figure out, oh, there's 3 where it's false, 1 where it's true, depending on the truth values of everything we have. We're going to skip 3, and we're going to go on to 4. How many statements do I see here? 2, P and R. What's going to follow P and R?
Not P and not R.
Not P, not R, negations. And then last but not least will be our compound statement, not P and not R. I want you guys to try filling this one out. So what's the very first thing we do on these? What we made a habit of doing on these?
Trues and false.
Trues and falses for our P's and R's, our normal statements. So what are we going to do for the P's? True, true, false, false. First half, second half here, okay? What am I going to do for my R's?
True, false, true, false.
True, false, true, false. I'm going to alternate them. Okay, now not P. Well, we can say, well, that's going to follow from the first column. So it's going to be the opposite of the first column was. So the first column was true, true, false, false. So this will be
False, false, true, true.
false, false, true, true, true. The fourth column, not R, will follow R. Just be the opposite. So instead of true, false, it'll be
False, true, false.
false, true, false, true. Now for not P and not R, which two columns am I actually looking at?
Third,
Not
fourth.
P.
The third and the fourth, not P and not R. Now do I need both or one to be true?
Both.
Both. So can somebody read me what I would have row by row?
False, 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 true.
Questions on this one? Okay, look. You need to go to the bathroom? Okay.
I think notes are over for today.
Okay, not quite. We're going to skip number 5. Okay, we're going to practice 6. P or Q and R. What do parentheses mean?
I do not
You
know.
know first.
You do those first, same as in math.
This is
Okay.
wow.
Now, this got bigger, right? This got bigger. Okay, and they get bigger and bigger and bigger all the way through. Now, number 6, we're still going to start off the same way. We're going to put all of our normal statements first. So what normal statements do we have this time?
PQR.
P, Q, and R.
Oh, that's not bad.
Then we're going to put disjunctions and conjunctions. But we're going to work inside out. So we're going to do the one inside the parenthesis first. Q and R. Because we have to do that first. Because parentheses tell us it comes first. Order of operations. And then our last one is going to be our very big one. P or Q and R. Because that's what we're really trying to figure out is at the end of the day, what's the whole thing end up being? So our last one's always going to be the whole thing, because the whole thing is always going to be one giant conjunction or disjunction. So now for our P's, we said we always want to organize these how?
True,
Half
true,
true,
false,
half
false.
First half true, second half false. So true, 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 false, 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 false. Now this is where it gets a little bit different because now we have 3 statements rather than 2. So when we had 2, you just said the second one we alternated. We don't want to alternate here though. We actually want to do a different scenario. We want to go double true, double false, double true, double false. So that way we have some 2 scenarios where P is false but Q is true. 2 scenarios where they're both false. 2 scenarios where they're both true. 2 scenarios where the first one's false, first one's true, second one's false. Yes, Max.
We would then alternate the R, right?
You would alternate the R. So you always alternate the last one. True, false, true, false, true, false, true, false. And now if we look at these 8 scenarios we created, they are all different.
They are. They are.
And but we cover all of our bases. First one, they're all true. Second one, the first 2 are true. The third one, the first and third are true. And so on and so forth. They cover something different every single time. It's just a nice pattern that we use to fill these in. Questions on that?
I do not.
Okay, from there, we go to our next column, Q and R. Which 2 columns are we going to look at for Q and R?
Q and R.
Q and R. And, so how many do need to be true?
All.
Both. So, Q and R are both true, so what's the first row? True. Are there any others where it's true? Yeah, later on, but for a while, true and a false, false, false and a true, false, false and a false, false, true and a true, that's true. Questions on that? On how we got this 4th column. So now the 5th and final column, P or Q and R. Which 2 columns are we actually looking at now?
The
P
or R.
and then the Q and R. So we're looking at our first and our 4th column. And because it's or, how many need to be true?
Oh no.
So we're just going to look for when at least one of either P or Q and R are true. So can somebody read me what this one might be? False. So this looks really intimidating at first, but once we can figure out the pattern of how we set these up, which is, I think that's the tough part. That way we can get them there, okay? And we will have some questions if we need them, okay? Any questions on this one right now? Okay, so when we had 3 compound statements or 3 statements in there, first one does first half, second half. Second one, we're going to do double true, double false, double true, double false. Then we're going to alternate true, false, true, false, true, false, true, false, true, false to get all of the scenarios. First one will always be first half, second half. Last one will always be every other. Questions on that? Okay. We're going to skip 7. But we're going to try 8 together. Okay.
How would you do that?
Okay. So we start off with what every time? P. Bless you, must rain down after the script. Then what? Bless you, must rain down after the script. Q. Then what?
R.
Then R. So we're going to start off with the normal ones. P, Q, R. Then we're going to start with any negations that exist. Do we have any negations here?
Yes.
What do we have?
P and negative R.
Yep, not P and not R.
Negative.
Then what am I going to put? I have 2 rows left, or 2 columns left, so what am I going to put?
Negative P
Or
Q.
Q.
Okay, not P or Q. I'm going to put my compound statement that's in the parentheses. Then what am I going to put? The whole thing. Very good. Not P or Q in parentheses.
R.
And
Not
not R. And once again, this looks super intimidating. We're going to break it down piece by piece. So let's do one column at a time. So how would I do my P's?
True.
4
False,
true,
false,
4
false,
false.
4 true, 4 false. First half, second half.
Double it.
Okay. What would Q be?
Double alternate.
Double alternate. So double true, double false. Double true, double false. What would my R be?
Alternate.
Every other. True, false. The true alternating. True, false, true, false. True, false, true, false. Once again, if we look at these, we create 8 different unique scenarios. Now look at not P. What would not P end up being?
4 falses.
4 false, 4 true. Just going to flip from whatever the P was. What about not R?
Opposite alternate of the R.
Alternating, but start with the F. Okay, we're going to opposite of whatever R was. False, true, false, true, false, true, false, true.
Boom.
So we're just going to work these one column at a time. Not P or Q. How many need to be true out of these two? 1. Not P and Q. We're going to look at the 4th column and the 2nd column. So just look at the 4th and the 2nd column. Make sure you don't get off here. That's where it gets tricky, okay? So can somebody read me what these would be? True. 1 second. True, true, false, false, true, 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 true. Questions on that part? And then the last one, even though this looks really scary, we're really only looking at 2 columns again. Which 2 columns are we looking at?
The last two.
The last 2 before it, right? Not R and not P or Q. And what's the by conjunction or disjunction?
Both
It's
true.
and. So they both have to be true. So I have to look at my last column, and if they're both true, it's true. If they're not, it's false. So start with false, then what?
True.
Yep.
False, 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 true, false, true.
Okay. Questions on that one? Bill. Just to make you cry. That's my goal. Good, good. I'm working on it. Okay?